let's say on the water boiler, I think it came out to the difference was about like 5 minutes full power to 10 minutes at lower power. Okay, you're still using the total amount of watt hours, we'll say. So you didn't save any power. So think about that. You're not saving any power, but you're using a lower power for a longer period of time, and maybe your system can handle that where it couldn't handle full power. Probably 2 or 3 months ago, I started to shoot in a series of videos that I was going to release. I got a couple things here I want to show you. This one is called the Kill A Watt, like Kill space A space Watt. This is the version P3. I don't know if it really matters. It'll handle up to 15 amps, 1800 watts. Okay. The idea is you plug it into your socket, and then it'll give you a readout on the screen. And I didn't bother bringing a cord out here. But you can see how many volts are coming in. Typically, that's where it'll start. You should be 115 volts if you're here in the US. And then amps and watts will show you how much power the device is using that's plugged into here. So you plug this side into the wall, and then you plug your device like a coffee maker into here, and you'll be able to see a real-time output of how many watts are going through this meter, which is really handy. If you're living off-grid already, or if you're thinking of moving off-grid, this is like a really handy device so that you can kind of get an idea how much each device uses. So for instance, you might just decide, you know what, maybe the coffee maker is just using more power than what you can handle, based on how big your solar system is or how many batteries you've got. Okay, it gives you kind of a starting point. So a lot of the things in my house, I have written down on a piece of tape or something on the side of the device, okay, this coffee maker uses 625 watts. This is labeled fan speed controller. I found this on Amazon. I actually bought it specifically for controlling the speed of my electric fan, because it always seems like medium is too fast and low is too low. This works with AC circuits, okay? So again, you got this end that plugs into the wall, and then on the bottom it's got a regular grounded plug-in, and this is rated at 15 amps also, okay? So just about anything that you can plug into a plug-in, this will be able to handle. You got a 3-position switch off in the middle, full power is number 1, and variable is number 2. So if you just want to turn it on regular, you just hit the number 1, go on full power, and it's just like as if it was a switch that turns on your device. Okay. If you go to variable, you can use your dial here to change all the way from almost nothing up to full power. And then full power here is about the same as hitting here. Don't use this with your microwave. That would be probably a bad idea because the electronics would freak out. I've tested it with my sump pump. I can slow down the flow of water coming out of it. I've tested it with a hot plate, which we'll show in the video. I've tested it with a water boiler, which is in the video coming up. So fans, pumps seem to work, but I would say be careful with it. If it sounds like it's stalling, the motor, stop so you don't burn out the motor. If I turn on my big 40-cup coffee maker at full power at 7 o'clock in the morning before the sun is even hitting the panels, the power I've got left in the batteries just isn't enough, and it's going to knock the inverter offline pretty quickly because it's just going to pull 1200 watts until the batteries can't handle it anymore. The battery voltage drops down to 10.8, and then the inverter says, oh, see ya, beep, and it faults out, and then you got no lights. Okay. So what I was looking at, and this actually is working with a lot of the devices I've tested it with, if I can set this dial to a lower setting, instead of my coffee maker pulling 1500 watts, we'll say, maybe I can turn it about here and it'll only pull 1000, and I can pull it to here and it'll only pull 500 watts. Okay. If you're pulling less watts, maybe you can keep your inverter from kicking off, but I was actually able to still boil water in a little water boiler at a lower setting. So it just took it longer to get there, but it actually still worked. And the issue is with the hot plate, the water boiler, my electric water heater, my electric frying pan, the coffee maker, when you turn them on, they go full power. There's no in between. The hot plate, even though it's got a dial on it that you can turn up or down, it still pulls 1000 watts even at the lowest simmer setting until it gets up to its own temperature, and then it shuts itself off. And so you could look at it like on a graph or something like that. It just goes 1,000 watts. Okay, we're up to 100 degrees, drops down, waits for the temperature to slowly drop down. Okay, it's at the lower threshold. It kicks it up to 1,000 watts, and then it goes up, and it kind of goes up and down. What I was hoping to do is, with a limited amount of power, could I eventually heat up water? Okay. What I was finding, and this is in the winter, I tested this in January and February, I was able to slowly bring up the temperature of my water in the hot water heater so I could take a shower. But it was going to take it longer than all day to get it up to warm enough because it was so cold out. So the water was starting at very cold. Like we're talking, just above freezing probably at that day. So it was taking a long time, and I would just keep knocking the inverter off so I could run it for a few minutes and then shut it off, let the batteries catch up, run it for a little bit, shut it off, kind of cycle it up. But every time it got a little bit warmer. Off-grid, if you're looking to heat something up, you can't beat propane. Seriously, you can go buy propane. It's very inexpensive. If I had thought about it, I probably would have bought a propane-powered water heater instead of an electric, right? It just made more sense. But because the next thing I want to do is build a windmill, then I could have the wind blowing and heating up my water. That's kind of the idea with this. And if you use this and this together, first you can say, okay, this device uses 1,500 watts at full power. And then when I hit the switch over here to go to variable, I can dial it down. If I knew it was 1,500 to start with, I can dial it down to say 700 or 500 watts. And it'll just take that much longer to heat up, but a 500 watt load on the batteries is much easier on it than a 1,500 watt load is. The water heater for a shower will take it half an hour. Well, maybe if it took 4 hours, I can do that. I could heat water up during the middle of the day when I've got the most solar and it's an insulated tank. Maybe I could have a hot shower that night without running the generator. That's kind of the way we're looking at it right now. So this is called a fan speed controller. I've actually seen in I think it was Harbor Freight, they're selling exactly the same thing. It looked like just the same label, the same markings, everything. I think they are labeling it as a router speed controller, which would be the same idea. You could hook it up to like most electric motors and slow them down or speed them up based on the dial here. So if you had a fan that was running too fast, or if you wanted to slow your router down, you could maybe do that. Or you could use it to maybe do an electric speed control for your drill press if you wanted to slow it down, and maybe you didn't have enough options on your pulleys. You could slow it down a little bit with that. That might be something you could look at it for. Okay, so these are available. You don't just have to go to Amazon to buy it. You could probably pick it up in a lot of hardware stores, something similar to this. I did test it on an electric heater. I've got one of those little dish heaters that glows red and it reflects all the heat to you. And this did not work with that because the idea is the dish or the heating element has to glow red. And this was stopping it before it actually got to red, right? So I was like, yeah, it's not going to work. So that was one that didn't really work very well. So that kind of gives you an idea, these together, and this by itself even, the kilowatt, it just helps you learn how much power everything uses. And then you can make a decision. Like for instance, if you haven't moved off grid, plug your air conditioner into this thing and get an idea. And that'll kind of tell you, okay, if your air conditioner uses 2,000 watts, you're going to need a generator at least that big to run it. Okay, which means the whole time you're running the air conditioner, you got to have the generator going. This is also good if you're going RV camping or something like that. Maybe you just don't have enough power to run that thing, so you got to make a different choice. Literally kind of change the rules. How much power does it actually use? You can change that. Let's say on the water boiler, I think it came out to, the difference was about like 5 minutes full power to 10 minutes at lower power. Okay, you're still using the total amount of watt hours, we'll say. So you didn't save any power. So think about that. You're not saving any power, but you're using a lower power for a longer period of time, and maybe your system can handle that where it couldn't handle full power. Okay, I just started the coffee maker. It's about 24 cups, a little less. So what I want to do, instead of screwing with AC right now, Let's just see if I can figure out how many amps DC I'm pulling. Okay, this kind of goes fast, so here's what you want to be looking for. First, I'm checking the amps coming out of the batteries. I'm getting something like 90 amps going from the battery to the power inverter that's supplying the AC power to the house. Then I wanted to check how much power is going between the two batteries. That's showing me how well my load balancing is working. And I'm getting approximately half of the amps from each. So if I got 90 amps coming out of the batteries, how much power is coming in right now off of the solar system? Okay, so that's the next thing we're going to look at. In this case, I've got between 9 and 10 amps coming into the batteries and 90 amps coming out. So that's almost 10 times as much, right? 9 times, 10 times as much. So I couldn't run that coffee maker continuously, but I can get away with running it for a shorter period of time because of how big the batteries are. And that's really the key with solar. Solar is like a dripping faucet. You're getting a little bit of power coming in all through the day so that when you need it, you've got enough power to make your pot of coffee. So that's kind of what you're looking for here, all right? Okay, so we're brewing, so this should work like that. Yeah, so we're pulling 92 amps DC right now. Okay. Now something I've always been curious about, if we got 91, 92 there, how about between batteries? 52, 53, that's almost half. Okay, so that's actually good. And then I can check how much charging am I getting. So I'm pulling 10 amps in right now, according to that. And that shows 9 amps on here. That's almost exactly right. Okay, good. This is useful. Red light for power and green light is when it actually is heating. So I'm going to turn it all the way off. Okay, 0 watts. When I first turn it till it clicks on. Yeah, it jumps right up to 1,000 watts. I was wondering if I could have a lower watt setting. That's on max, it's still pulling 1,000 watts. So it doesn't have an in-between. It's just going to be on or off. So since that's going, I'm going to heat up some water or heat up some coffee on that. Coffee's pretty warm already. Okay, that's glowing red. That's a good sign. So I'm going to turn this thing way down again. I don't need to burn the coffee. Oops, too much. Okay, so yeah, it pulls about 1,000 watts when it's heating. Okay, so I got a kilowatt mounted here. I'm showing 115 volts. This is coming off of solar in the inverter. Okay. Down here, I've got an electric hot plate. I did this part of the test before. The problem is the hot plate on low or on high or anything else, it pulls 1,000 watts and then it gets up to temperature and then it shuts off until it cools down. It's a thermostat kind of a setup, right? So even like if I just turn it on just a little bit, the light's just dimmed. I'm going to read off the numbers because you can't see it. But it's 918 watts right now. And it doesn't matter how hot it's set here. If I crank it all the way up to max, it's still 919, 920, 916, 917, right? And then when it gets to that temperature, the lights come back on and it drops down to 0 watts. Okay, so what I remembered I had, this is it's labeled as a fan speed controller, okay? So let's turn this thing off. I'm going to just see if this works or not. I'm going to plug the fan, or plug the hot plate into this, and then plug this into the kilowatt. And this has an on, so it's off in the middle on here. Full power is just straight through, and variable is variable. Okay, so if I turn it all the way down, turn it on to variable, I got no watts. Oh, and then I'm going to turn this thing on so that it clicks. That is pulling 350 watts right now. Okay, I'm going to just leave it on low for a minute and just see what happens. This is on max, it's just going to stay on. It's working. Yeah, it's getting warm. So this is my question. If this thing doesn't go nuclear on me, can I take a hot plate that would normally run at about almost 1,000 watts, and can I lower the amount of current that it pulls? Okay, because this is pulling about 1/3 of the normal current. It'll take it obviously longer for this to get warm, but this is just a simple resistance load. So if I could, over time, warm something up, right? The idea is that would take less of a hit off of the batteries. If I'm sitting here and I just barely got enough, like for instance, I can run my Raspberry Pi little computer for a long time because it doesn't have very much of a load, and I can run the inverter all the way down to less than 11 volts and it won't fault out. But if I turned on my water heater that pulls close to 20 amps, yeah, it'll just pop it right away. It'll just like, nope, not gonna work. Okay. Now obviously this is gonna take forever, but it is generating heat. Okay, so at roughly 330 watts, if I just start turning this up, I want to see how granular it is. Okay, went up to 378 when I got almost to medium. I can hear a sound change here, so I'm going to see if I can set it to about 500 watts, so it's about half power. It's funny, this makes noise. You wouldn't think it would. Okay, so right around here is roughly 500 watts, 490 and up just a little bit. Okay, so that's about 500 watts right there. Now it's getting warm. And then if I change the switch and hit it to full here, now it jumps up to about 900 watts, okay? And the light's dimmed. But here, the lights are not dimming. That makes it interesting. So it's about 65 degrees in here right now. It's not super cold. So I'm just curious. I want to see how long it would take this to get warm. Like it's basically cold now. Maybe a little bit lukewarm. Okay. So I'm going to use that for washing dishes. I just want to see how long it would take. So it's obviously putting a load on the batteries, but it's not a super high load. I can feel heat coming off of this. The gold standard test on testing something is to see if it's generating heat. There's a warm spot back here, but it's not hot to the touch. That's generally okay. Okay, that's less than 500 now. Let's see if we can just bring it up a little bit. I kind of want to see at what point does my lights start getting tweaky in here. Okay, it's 600 watts. Yeah, I can see my lights starting to dim at about 700 watts. That's pretty funny. The microwave will typically dim the lights, and the coffee maker usually will too. So I'm back down to about 500 watts. That's totally working. It's definitely warm now. Like it's almost too hot. It'd probably be too hot for a bath now. I'm just starting to get steam off the water now. That's awesome. Yeah, it's definitely getting hot. Shit, that's cool. Okay, I'm going to shut this thing off. Lights got a little bit brighter. I'm going to shut this one off. And we're back to 0 watts. How cool is that? Okay, I'm not sure if the display is going to show up, so I'll read that off. But I've got the kilowatt here in the background. This is loaded up to about 1 liter of water. This is a Hamilton Beach 1 liter water heater boiler kind of a thing. It's supposed to auto shut off when it hits boiling. Okay, I got the generator on. I'm going to do this test again where I got enough power. Okay, stopwatch starting in 3, 2, 1, go. 5 minutes, 15 seconds, 1240 watts, 5.5 minutes. That's boiling. Click. So 5 minutes, 40 seconds, approximately. And then it drops right down to 0 watts. That's kind of cool. Okay, so we're on, we're down to 11.6. That's 1240 watts. Pretty good load. Okay, so let's put it on variable. I'm going to dial it down. Let's see if we can hit 500 watts. Actually 600 looks good, because my coffee maker is 650. I love that I can just dial it right in. Okay, so 600, 603, that's pretty good. Okay, so now my battery's at 11.4. And I'm just going to let this run and see how long it takes. Oh, look at that. Perfect. I just want to see, will it boil at all? Because right now the water is close to freezing still. Air temperature in here is up to 42. So it's pretty good load. What I like about this speed controller is it's got the A/B switch on it, so I can just go full if I've got lots of power and I just don't care, kind of thing. It's almost 10 o'clock in the morning, so we're coming into peak solar. 11.1 now. Just a little bit of light cloud. It's like not quite blue sky, but it's just like very light haze, mostly clear. Water's up to 137. It's just starting to make noise, so it's definitely getting warm. That's plenty hot for 143. That's plenty for washing my hands. Let's just let it run until it boils, see if it does. So if we're up to 143. It's 38 in here. 38 degrees according to this, so that's 100 degrees warmer. That's doing pretty good. Yeah, because if this will work, I don't care if it's super fast necessarily, right? So let's say I wanted to make my oatmeal with this thing. I could dial the amps down. It would sag the battery less. Steam coming off the water, it's showing 160 degrees now. And I'm at 10.9 volts. 180 temperature. We're 8 minutes in. It's boiling. That's awesome. So it should kick off any time now. 10 minutes. Yep, just kicked off. And the watts dropped down to nothing. Freaking cool. So about 10 minutes. And that was 0.75 liters. I don't need anything near that much. So I can make hot chocolate with that or something now.